Hi, I'm Jessica at One Energy. Welcome to today's Science Short. Today we're going to dive into the world of gravity to learn why objects fall and how it's much more complicated than it seems. Gravity is what makes life on Earth possible. It's what makes this ball fall to the ground. It's what keeps our feet planted on the ground. It's what keeps the Earth orbiting around the sun. Without gravity, we'd all just be floating around aimlessly around a universe that was never created in the first place.
Whoa, that's deep.
Let's get started. To explain gravity, we have to discuss the findings of two great scientists, Albert Einstein and Sir Isaac Newton. In the 17th century, Sir Isaac Newton discovered that all objects with mass tend to attract other objects with mass along a line intersecting the two objects. He figured out that how much the objects are attracted to each other, or in other words, how much gravitational force is pulling the two objects together, is inversely related to the square of the distance between the two objects of mass. That means the further apart the objects are, the weaker the gravitational force is between them. Objects twice as far apart have a gravitational force that is 1/4 as strong. Newton also discovered that the gravitational force between the two objects is directly proportional to how much mass those objects have. The more mass, the stronger the gravitational force. So what's an example that can explain the relationship between distance, mass, and gravity? Let's look at the Earth, the Moon, and the oceans. There is a gravitational force between all four of these objects. You and the Earth are attracted to each other. The Earth has a pretty large mass, and you and the Earth are pretty close together, so your attraction is strong enough to keep your feet touching the ground. You and the Moon are also attracted to each other. But because the Moon is so far away and you're relatively small, you don't feel the same attraction as you do to the Earth. The oceans, on the other hand, are much bigger than you, and they do feel some attraction to the Moon. This attraction, while somewhat weak because of the great distance between the oceans and the Moon, is what gives the oceans their tides. How gravity influences objects relating their mass and their distance can be mostly approximated by Newton's theory of gravitation. You might hear it called Newton's law of universal gravitation, but it's not actually a law at all. It's a theory. This means that it doesn't apply in all cases. Newton's theory is, for the most part, a good approximation of gravity and can predict movement of objects in our solar system, like the Earth and the Moon and the Sun. But it doesn't do a good job of explaining very, very large masses or very, very small masses. To understand these two extremes, we have to look at another scientist. In the 20th century, Albert Einstein determined that in very, very strong gravitational fields, Newton's theory doesn't apply. He also determined that gravity doesn't just apply to objects with mass, but also applies to objects with energy, like light. Black holes, for example, have very, very strong gravitational fields. Einstein determined those fields are much better explained by his theory of relativity than by Newton's theory of universal gravitation. But let's stop right there. We won't get into Einstein's theory of relativity today. That's far too much for one science short. To wrap it up, gravity is the attraction between two objects. It's impacted by the size of the objects and the distance between them. The gravitational force here on Earth is about 9.8 meters per second squared. On the Moon, it's about 1.6 meters per second squared, because the Moon is much smaller than the Earth. That's what gave Neil Armstrong a little more bounce in his leap for mankind. Thank goodness for gravity, because if it weren't for gravity, none of us would be here at all. That's it for today's Science Short. Be sure to subscribe to our YouTube channel to catch the next episode. Thanks for watching, and remember, challenge everything.